Hi, pre-algebra students. This is going to be our first lesson of 3 on inequalities. Specifically, in this lesson, we're going to focus on writing and graphing inequalities. The warm-up questions are currently on the screen. Again, I encourage you to pause this video, try numbers 1 and 2, and then come back to get the answers. These are really going to help you get in the mindset that we need for this lesson. So I will see you back here in a moment with some answers. Alrighty. Hopefully you have tried numbers 1 and number 2. Number 1 is asking you to match the phrases that mean the same thing. So on the left, we have the phrases the same as, no more than, and at least. And we're matching those with less than, a minimum of, and equal to. The first one we have is the same as, means the same thing as, equal to. Both of those, if you saw those words in a story, we might use an equal sign or an equation to represent that story. These other ones, though, do not mean equal to, and that's why I said this is great practice to get you ready for today's lesson. The first pair we have of these ones that are left is no more than. No more than is saying it's not more than, which means it must be less than. So both of those would be using a less than sign to help you represent them. And then that final one, we've got at least and a minimum of. Both of those mean the same thing. I want to talk a little bit more about that pair, especially the word at least and even the word minimum. You might hear the word least and minimum and think least and less. Those mean the same thing. If you say at least, or if you say a minimum of something, for example, I want to make at least $100. If I say I want at least $100, or I need to make a minimum of $100, that means $100 or more. Those words at least can be tricky because you see least and it looks like the word less, but it actually means the opposite. Least would mean we're talking about numbers greater. Again, this is going to be practice. It's going to be good practice for these next 3 lessons we're working on today and the next 2, where we're using inequalities to help us represent and solve problems. Problems such as number 2. In number 2, we've got my classroom can hold a maximum of 15 students. Those words maximum, similar to above, are going to be keywords to help us understand what types of numbers we're talking about. The direction said give 3 examples of possible amounts of students that could be in this room. So for example, if my classroom can hold a maximum of 15 students, that means my room could have 10 students in it. My room could have 2 students in it. My room could have 14 students in it. I'm picking those numbers that are less than 15. Now, if you say a maximum of 15 students, that also is including the number 15. Maximum of 15 means we are talking about 15 or less. Again, these are the vocabulary words you are going to hear throughout these next couple lessons as we talk about inequalities. Now, I keep talking about this word inequality. If you had me for developmental math, the class that comes before this one, we talked a little bit about inequalities, but we can always still use a reminder. I'm going to jump down to part 1. Our goal is going to be using inequality symbols to help us write these inequalities. And an inequality is just a statement that compares 2 unequal amounts. So as a quick reminder, our inequality symbols in developmental math, we use the less than and the greater than symbols. In pre-algebra, we're actually going to use all 4 of them. You also have a less than or equal to symbol and a greater than or equal to symbol. Sometimes you're just talking about numbers less than. So for example, if I say I want, what's something I want less of? I want less than 10 problems to do for homework. That means only numbers less than 10. So like 9, 8, 7, 6, 5. But if I say my room can hold a maximum of 15 students, that's numbers less, but also equal to 15. That's when I would use the symbol here, the less than or equal to symbol. So our goal for today is we're using inequalities. We're using these symbols to help us do two things. I can represent situations with inequalities and graph the solutions on a number line. So two parts to today. What we are using in today's lesson is going to be skills that we continue to build on and use in the final two lessons in this unit. So we're starting talking about inequalities today, but we'll continue talking about them in the next two lessons as well. To give you an idea of what we're doing, this whole idea of representing situations and then graphing them on a number line, we've got this story here about Heather. Go ahead, take a moment to read through the story. You can pause the video if you need. And as you're reading through it, I want you to see if you can find a key word that's going to help us decide what inequality symbol we need. Keywords are similar to these words we've been looking at up here, like no more than, minimum of, at least, maximum. All of those are keywords that are going to help us decide, do we need a greater than sign or do we need a less than sign? Again, pause the video if you need, but go ahead, read through this story about Heather, and then come back when you think you have an idea. All right. Our story about Heather says Heather got a 65% on her math test. She did more practice, and after retaking the test, she scored higher on the retake. Our job is to write an inequality. And this word inequality is really important now. When you see those directions, write an inequality. If you know the word inequality means this stuff, that helps you know we need to decide, am I using a less than or greater than sign? It's not going to be an equal sign because I did not tell you to write an equation. The way we decide what we're going to use to write an inequality to describe our retake score is going to be information from the story. As you were reading through this, maybe you highlighted the word higher. If she scores higher on the retake, that's telling me she scored greater on the retake. So when I go to write my inequality for part A, I'm describing the retake score, which we're using the variable S to name our score. I'm going to say her retake score is higher, and that I'm getting higher means greater than. Her retake score is greater than, her original score is greater than 65. I'm combining those three things to get this inequality here. Now, just like with equations, notice inequalities don't have words in them, don't have symbols like percentage signs or dollar signs in them. It's just the pure math. But this inequality represents the story. A quick note for when you're doing homework or tests, if it asks you to write an inequality, you are never just going to put an inequality sign. You need everything we just wrote. You need stuff on both sides. So this inequality here represents their story. We've got our retake score needs to be greater than 65. We do have two types of greater than signs. We have a greater than sign and we have a greater than or equal to sign. Any idea why we're using the greater than sign and not greater than or equal to? Well, it's going to come back to the story. We highlighted this word higher. Higher means only greater than. If she scored a 65 on the retake, she didn't do higher, she did the same. And so that's how we help decide between greater than and greater than or equal to. It's going to be based on words in the story. Now, this is one possible answer. Did you know, though, that there is another thing you could write down? Any idea what that other thing might be? If you're unsure, we've seen something similar with equations. When we've solved equations, maybe you get x equals 3 or 3 equals x, and we've said how those mean the same thing. You've just flipped it around. You can see that same thing with inequalities. With inequalities, though, again, we have to be really careful with that symbol. You could see S, her retake score, needs to be greater than 65%, or you could see 65% is less than her retake score. Notice when I flipped it around, I also had to change the inequality sign. The second one saying like her original score is less than her retake score. The first one saying her retake score is higher than her original score. They both correctly represent the story, but depending on the order, you might use a different inequality sign. Now, I will say for a lot of us, this first one is easier. For a lot of us, it's easier to start with the variable. However, both of these would be correct. This is the first thing we're trying to do today. We said our goal is to represent situations with inequalities, and this is going to be like the foundation that we're going to continue to build on in the next couple lessons. Once we have an inequality to represent our story, we can start thinking through these final pieces about what this means. When you say S is greater than 65, we're saying her retake score needs to be greater than 65. What are some of those possible scores she got on the retake? I didn't tell you her retake score, but you can give me some possible answers. Go ahead, pause this video now and try to write down 3 possible numbers. Well, if she scored higher on the retake, maybe she got a 70%. That would be higher. Or maybe you said she got an 85%. That would also be higher. Maybe she got 100%. All of those would be higher. Or maybe you wrote down 3 numbers that I did not put up here yet. When I do this in class, there's more people in the room than just me. And so what I have us do, instead of listing them all out, is I start to record them on a number line here. So for example, if maybe you said 70, we could mark a point right here at the number 70. That's a possible score she got. Or if you said 85, I know 85 would be right here in the middle of 80 and 90. Or if you said 100, that's easy. That's here at the end. Or like I said, maybe you said some other numbers. Maybe you said, well, higher than 65, that's 66. That's a possibility. Or 80, or 90, or 75. And usually at some point in class when I'm doing this, right, because I keep asking, is that all the possibilities? Is that all the possibilities? And people keep giving me more possibilities until someone goes, okay, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, and tries to name them all. But then we realize, well, you could also get something like a 95.5%. And so if there's any spaces left here, they're definitely all getting filled in with even more points. And that's just from 90 to 100. If we kept doing this, and if we spent the rest of class with you all telling me all these different points, it's going to stop looking like a bunch of points. And look at this now. It doesn't look like points anymore. It just looks like I've colored in that number line. When it comes to graphing inequalities on a number line, you are not going to be putting a bunch of different points. What we do, though, is we color in or shade part of the number line that includes the numbers we're talking about. All of these different possibilities that we're listing are all numbers greater than 65, right? So if 65 is right here on our number line, I would be shading or coloring in everything on this side of my number line. Those are all the numbers that are greater than 65. There wouldn't be any points to the left because none of those numbers are higher than 65. This would be the first part of creating this graph. But there's a second part to this. We're trying to color all the different numbers that would be higher than 65. And I'm getting really close to that 65, right? 65.1% would be higher, not a lot higher, but it would be higher. But we have this question at 65. Are we talking about numbers at 65? Well, if you come back to the story, we're trying to describe her retake score. And if we know her retake score is higher, 65 wouldn't be a possibility. If she got 65 on the retake, that's not higher, that's the same. So 65 is not a possibility. I'm going to write that down up here. 65 is not a possible solution. Remember, solution means answer. So 65 is not a possible answer. It's not a possible retake score. The way we show that on our graph then is we want to show 65 is not a solution. 65 is not colored in. I'm coloring in all of these different numbers her retake score could be. To show 65 is not a solution, we do this right here. And let me zoom. Oh, sorry. Let me zoom in just to be really clear what I'm putting there. There you go. We do a circle like that to show that 65 is empty. There is no point there at 65. And we call that an open circle. An open circle means 65 is not a solution. We are coloring in all the numbers our retake score can be, and 65 is not colored in. Now, you might have an idea. If this is an open circle and it means 65 is not a solution, what do you think I would want to do if I did want to show 65 was an answer? We do everything the opposite. So instead of a circle that's not colored in, I would do a circle that is colored in. Instead of calling it an open circle, I would call it a closed circle. And I would use this if I wanted to show 65 is a solution. So if I said something like she got at least 65% or higher, that would mean we are talking about 65 as a possible retake score. So this right here is a good summary of what this lesson is all about. I'm going to zoom back out a little bit now and go back up to our goal for today. We said we want to represent situations with inequalities. That's what we did here in part A. And then what we are doing here at the end on our number line is that second part where we graph the solutions on a number line. The reason we do this on a number line is because if you were trying to list all of her possible scores, that would take us the rest of class and we still wouldn't be done. Because remember, there's all those decimals. The number line is a great way to show all of those possible answers, all of those solutions without having to make a list and write them all out. I can just look at this number line and know if it's colored in, like 80% is colored in, that would be a possible answer. So this piece right here is what we're going to spend the rest of this lesson practicing. The second part of this lesson is going to be a matching activity where below I have 3 more stories. All of these stories involve the number 9, and we are going to match these 3 stories with 3 number lines and 3 inequalities. I'm going to back this out just a little bit so it can all fit on the screen. And this is here for practice for you all. So again, you are going to pause this video because it's really important you're getting this practice. You're going to pause this video and try to do this matching activity. They're all lettered for you. So in your notes, you can just write, I matched letter A with D with G, or however you think they match up. Pause this video to try this, and then once you've got all 3 of these matched how you think they go, come back to get some answers. And you are back, hopefully with some answers. As we read through these 3 stories, how I want to start is the same way we started with Heather's story. I want to find that key word, like higher, that's going to help us identify which inequalities we're matching it with. So for A, we've got Lynn needs more than 9 ounces of butter to make cookies for her party. That phrase more than is going to be what helps us identify the inequality. In B, we have a food scale can measure up to 9 kilograms of weight. That phrase up to 9 is going to be how we figure out our inequality sign. And then for C, we've got a magician will perform her magic trick only if there are at least 9 people in the audience. That phrase at least 9 people, again, is how we're going to figure out our inequality. Starting with the phrase more than, when you are talking about more than 9 ounces, more than, does that mean greater than or less than? More than is going to mean greater than. Now, with more than, if I look down here, both G and H have greater than signs. We also have to think about, am I including 9 Is it greater than or equal to 9 or just greater than? If you say more than 9, you are only talking about numbers more than. So that means we do not want it to be 9. We only want more than. So that would be our greater than sign, and we have figured out that A is going to match with H. Lynn needs more than 9 ounces of butter, means X, the amount of butter she needs to be greater than 9. Let's go ahead and finish up matching the stories with the inequalities, then we can go back and do the graph. For B, we've got a food scale can measure up to 9 kilograms. Those words up to 9, it might help to think about what types of numbers you're talking about first. Up to 9, for me, I literally picture like up to. So 9 is here, and it can measure any number up to 9. So that means 9 is the highest number, and we can measure anything up to that highest number, 9. That means I'm talking about numbers like 1 kilogram, 3 kilograms, 8 kilograms, any number up to 9. So those examples I listed, those are all numbers less than 9. I think this one can be tricky because you see the word up, maybe you think greater than, but we actually want less than. Up to 9 means we're talking about those numbers less than 9. Again, we've got two types of less than signs though. Are we talking about less than 9 or less than or equal to 9? The way we decide, again, is going to the story. If you say up to 9 kilograms, that's all those numbers less than 9. And it also is including 9. So we want the less than or equal to sign. It can measure anything less than 9 kilograms, and it can also measure food that equals 9 kilograms. Based on that, that helps me know that B must go with I. Up to 9 kilograms would mean X, the weight it can measure, is less than or equal to 9. I'm going to talk about this X is greater than or equal to 0 in a moment. For C, it's clear then C must go with G. If we talk about it, at least 9, we said this during the warm-up. At least 9 means 9 or more. And I'm going to put that up here, 9 or more. It does not mean less. At least 9 people is 9 or more, so we're using that greater than or equal to sign there. Once you've got this matched, that helps us identify our number lines here. So looking at Lynn needs more than 9 ounces, looking through these graphs here, more than 9 would be numbers like 10, 11, 12. So I can eliminate D. It's not going to be D. It's going to be either E or F. Maybe you use the open and closed circles to help you decide here. I see E has a closed circle at the number 9, and F has an open circle at the number 9. We said earlier more than 9 means 9 is not okay. We only want numbers greater, so I do not include 9, and that means it goes with F. Switching over to B, the food scale one, we said that's X is less than or equal to 9. There's only one graph showing numbers less than 9, so that makes it a little easier. It must be D. Less than or equal to 9 would be numbers like 8, 7, 6, all of these numbers that are colored in here. And I also noticed there's that closed circle there showing that it could also measure exactly 9. So again, that means this final one here must go. In green, we've got our magician will perform for 9 or more people. And so we've got 9, and then I can see it's more. There's a couple of things that I've saved for the end to talk through. The first one I want to talk about is why this graph looks different from the others. The graph for D and the graph in F, we just have it all shaded in the same way we did up here, right? We just colored in everything after 65. Here we've got everything below 9 colored in. For F, we've got everything above 9 colored in. But E looks different. It's not like a closed circle with everything colored in. It has these individual points. Any idea why that one has individual points? As you're thinking through that question, it might help to read the story again. I've got our answer started. When we look at these individual points, there are individual points at the numbers 9, 10, 11, 12, 13, 14. When you color in the graph, all those same numbers are colored, but there's also coloring, there's also shading, like right here. What number would be there? 12, 13, that would be 13.5. Or right here, 10 and a half. When you color in, you're talking about all of those numbers. Why is E not colored in? Well, if we go to the story, we are describing numbers X can be, and X represents the number of people in the audience. Why am I not coloring in anything? On everything? I'm doing these individual points because X can only be whole numbers. It's been a while since we saw this word whole numbers. Whole numbers is what it sounds like. It's complete numbers, not fractions or decimals or parts of numbers. Whole numbers like 9 people, 10 people, 11 people. She cannot have 9.5 people in her audience. And because she can't have 9.5 people in her audience, I'm not coloring in every number bigger than 9. That's what a shaded in number line would be. I'm just doing those individual points. So related to that idea of we really have to think about what types of numbers we are talking about. I said earlier I'd come back to this 0 here. For our food scale story, we said it can measure up to 9 kilograms, which helped us decide that's going to be X is less than or equal to 9, which got us to this graph here. But understandably, you might have had the question, well, why is this here? Why does it say X is greater than or equal to 0? Why can't we only say X is less than or equal to 9? Again, it goes back to what numbers are we really trying to talk about? If you're talking about what a food scale can measure, what weights, yeah, any number less than 9. But any number less than 9, if I look at a number line, I'm looking at the number line in my room, I see numbers like 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, -2, -3. Oh, wait. If we're talking about what weight a food scale can measure, we don't want all numbers less than 9 because you can't have -3 kilograms of weight. You can't have negative weight. And so the reason this is here is to say no negative numbers. It means really just we're talking about those numbers between 0 and 9. That 0 is the minimum, the smallest number we're talking about. Not everything less than 9. Everything less than 9 up until 0. This matching activity, I think, can be a little challenging because there's so many different things we have to think about, right? We're thinking about, are we talking about all numbers or just whole numbers with these individual points? We have these extra steps of thinking about, am I talking about any number less than 9? Or am I going to stop at 0? So if you're feeling okay after this matching activity, that is great, because I think it was a little more challenging. And if you're like, I'm still unsure, please know that this is something we are going to continue to practice in those next 2 lessons. This is not the end of looking at stories and trying to represent them with math, right? That's something we're going to do until you're done with math classes. What I do want to do, though, is make the switch from all of this was from stories, but we also want to be able to graph an inequality if there is no story. If I just tell you X is less than 2, graph it for me with no context. And so to help us summarize what we're seeing here, below I've got this table, again, that summarizes everything we've talked about. And I'm just going to go in and add some number lines to match all of these. Before today, everything we had done was related to equations, like x equals 2. And when you say x equals 2, the only number you are talking about on a number line is the number 2. You are not talking about 1 or 0. You're not talking about 3 or 4. You are only talking about that number 2. So we never graphed it because that's a very boring graph, right? You're just putting a point at the number 2. But inequalities are talking about lots of different numbers. So for example, x is greater than 2. If I found 2 on my number line, it's talking about all those numbers greater, all of those numbers to the right. But with x is greater than 2, you're not talking about the number 2, so we used an open circle. For x is greater than or equal to 2, it's very similar. We're talking about all these numbers greater than 2, like 3, 4, 5. Same thing here, 3, 4, 5. But the difference between these is that x can also be the number 2. So that's where we would use that closed circle. When you're deciding open or closed, it's all about, are we including 2 or are we not including 2? Similarly, for x is less than 2 and x is less than or equal to 2, both of those are talking about the numbers to the left of 2. The difference is x is less than 2 does not include 2 as a possibility, and x is less than or equal to 2 does include x equals 2 as a possibility. So again, it's that difference of, are we talking about 2, yes or no? Using this as a nice summary of everything we've talked about today, I have got 2 practice graphs below. As you are drawing these number lines at home, notice what I was doing up here. When you draw your number line, it does not have to be super detailed. You do not have to try to fit every single number in the world. The main one you need is the number you see, like -1. And you can always put a couple more numbers on either side if you want, but the most necessary number you need is this number. So don't waste a bunch of time creating those number lines. What I am going to have you do, though, is actually graph it. So using especially this row in our table to help you out, go ahead, pause the video and try these 2 practice problems, and then that will be the end of the lesson. And you're back, hopefully with some graphs. For this first one, in order to be able to graph it, we need to first be able to read it. So if you're still working on learning these inequality signs, find a trick that works for you. But we need to know that this says m is greater than or equal to -1. That's our first step. If I know m is greater than or equal to -1, that does mean, because it has that or equal, it does mean that we are including -1. So I want to use a closed circle. And then the other piece, since it's m is greater than -1, those are all the numbers that are bigger than -1, which would be all the numbers this direction. Remember, positive numbers are always going to be greater than negative numbers. So this right here, or something like this, would be your graph for m is greater than or equal to -1. And then for number 2, we've got x is less than 4. Because x is less than 4, that means I'm not talking about 4, only numbers that are less. So I'm using an open circle this time. And then the numbers that are less than 4 would be numbers in this direction, like 3 or 2. If you ever want to check to make sure you're shading the correct side, you can do the same thing we did really for equations and use substitution. Remember, we're trying to color all of the possible answers. So I could always pick a number I've colored in, like the number 2, and make sure if I substitute 2 into the inequality, it says something that's true. Is 2 less than 4? Yep. So 2 should be shaded. It should be colored in because we're coloring all the numbers that are less than 4. If you are a little unsure about where to color, that's a good way that you can always check your answer. This is the end of this first lesson on inequalities. Again, we're going to continue practicing representing stories with inequalities and then creating these number lines for the solutions. And in our next 2 lessons, we're just going to get to look at situations that are even more fun, have a little more going on, and also talk about how you solve inequalities, just like you know how to solve equations. So we'll be able to connect a lot of different things we've learned. Thank you so much for watching. I hope you found this helpful, and I'll see you back for our next lesson. Bye, y'all.